Hi, I'm Yash Sheth, and I like a double shot cappuccino with low fat milk.
It's one of those mornings. And I mean, normally I'm in your time zone, but today I am not. As you can see by the clothes hanging up beside me. Actually, dude, I'm in New York right now, and I'm in a hotel room that is no bigger than a shoebox. And the thing is so expensive for the like 5 nights that I'm here. I don't even want to talk about how much I'm paying. You walk into the room and you're already in the bathroom, which you have to traverse through the bathroom, and then you just get to the bed, which is like in the windowsill. So it's fun in New York, but it's good location, and I get
Yeah.
to enjoy the hotness of New York this week, and also biking around. I've been biking like crazy. But anyways, today,
Any MLOps meetups there?
so we went, yeah, on Wednesday there was one, and it was incredible. I got to meet a bunch of people that I normally just talk to through the screen. Super cool to see how the MLOps community is starting to meet in person again. And we're always looking in case you want to start organizing something around your city or town. Let me know because we're making it happen. We've got like a playbook that you can follow, and we can just run with it. And so anyway,
The London one looked really
dude, the
cool.
London one was
Yeah.
great. The Amsterdam one is awesome. Berlin, we've got some stuff happening. Especially, I'm looking for people in Denver. I was just talking to a guy in Denver, and he was saying that there's a lot of talent in Denver and a lot of like demand and desire for these things to happen. So anyway, today we talked with Yash Sheth or Sheath. I can't pronounce names, as you all know, probably by now, if you've heard me introduce anyone over the last 2 years. And he is the co founder and VP of engineering at Galileo. And Galileo happened to sponsor this episode of the community podcast. So if you are on the market for an unstructured data helper, this is the tool for you. They've got a really cool blog post that we will link to also if you want to dig a little bit deeper into what they're doing. We posted that on the MLOps community blog. Yash is an OG, man. Like, he's been in the game, especially the unstructured data game, for over 10 years. He spent the last 10 years at Google, where he was doing all kinds of stuff around automatic speech recognition. He was on the and leading the core speech recognition platform team. So the guy knows his stuff. What were your takeaways, Adam?
Yeah, no, obviously deep sort of knowledge and talent there. It was really cool to speak to him. For me, actually, there was the funny bit around someone mentioned recently that you might not need calculus to do machine learning and deep learning. And Yash Sheth was really interesting, and he talked about how back in the day you would need to really understand how the compiler worked for to be able to write software, right? And that's kind of gone away. Like I don't, right? So he pointed and maybe signposted a little bit that that's maybe the way deep learning is going to go, and these tools will become more abstract and more general purpose. So that for me was really quite cool to see how maybe some of the more experienced, brightest sort of teams in the world are starting to think about this stuff as a bit more off the shelf, configure over code, that kind
Yeah.
of stuff.
I also liked his hot take on synthetic data and how what he's seen
Mm-hmm.
as it causes more harm than good if you're not careful. And so and you also had experiences with that too, right? Back in the day, though. How long ago? What, seven?
Yeah, way back in there
I mean,
is the
there's probably
time.
been some
Less said about that,
updates
the better.
since then, but you still got to be careful if you're using that synthetic data. If you are
Yeah,
using it,
definitely.
reach out to us. Let us know how it's been going, and if you love it, I definitely want to hear from you because synthetic data, as you mentioned before too, it is a bit of a buzzword type thing. It's getting more
Mm-hmm.
popular.
Very trendy at the
Yeah.
moment.
So, all right, let's get into this podcast with Yash and definitely check out Galileo because these guys are doing some awesome stuff. That's it. First question, obvious question. I mean, you have an incredible background. What got you started down this path? What made you go into not only machine learning, but then why into the unstructured data field? And can you give us the decisions that were made along the way?
So yeah, I've been working on speech recognition at Google for the past 9 years, and you know, along the way, what we've learned is that in order to build world class models that can that power 20 plus products at Google across 80 languages, one of the key things that the team got it right was the ability to effectively understand the data sets and proactively fix gaps in the model before launching anything in production. And along the way, we also developed a key rigor to sort of understand data better and develop the tools for it. Um, that's my background and where where I've been working on. And what got me into machine learning is sort of a step further out. In I was in grad school, and machine learning was still very nascent, as data sets were scarce in academia. And we did machine learning in MATLAB and R, and the sophisticated tools that are there today weren't available back then, but it still was a very interesting field. And I was always fascinated about how math can be purposefully positioned into algorithms to understand features from data. So um, and fast forwarding to now, I think what got us excited about Galileo, and about the need for data centric techniques in on unstructured data, especially, is the need. I mean, the need for the required tools for the data scientists to be able to effectively understand data today.
So, wanted to ask the question: where does it fit in, like the workflow then? And when, like, would I, as I say, a fledgling data science team, start thinking, actually, when's it going to be the best bang for buck for me and stuff like that?
Yeah, so I think before we dive into that, I think I just want to highlight the the different challenges in the unstructured data workflow, and maybe that might lead us into sort of understanding when we need to apply these
That makes
techniques
sense. Yeah,
in
yeah.
our workflow. So, I mean, as we know, that over 90% of the world's information is unstructured today, and it's growing incredibly fast. There are estimates that it's growing at 55 to 65% every year. And with the proliferation of deep learning techniques, more and more businesses are starting to tap into this data to build modern AI powered applications, right? So I think a lot of the key challenges today are coming from not only the fact that there are sophisticated algorithms that work well on a variety of modeling tasks on unstructured data, and they generalize well across domains. But um, with unstructured data itself, the challenges that come in are, firstly, understanding that data and curating your data set. That's not only cumbersome, but it's not just about sampling data equally across the labels that you want to identify, because there are a lot of nuances within unstructured data, like different sources the data are coming from, different modalities of the data. Maybe there are, for example, within speech, in my experience, there are tons of speakers with tons of accents. So it's not just about what is being spoken, but how and in what environment. um, and uh, and so once you understand this, you can curate your data set better. But when you actually train your model, it's very important to understand where the model is making mistakes. So, and in order to really understand where the model is making mistakes, today, folks are using ad hoc scripts and looking at data dumps, individually, and trying to understand, oh, why is this sample bad for my model? And and so, in the past 6 months at Galileo, we've spoken to over 100 ML teams working with unstructured data. And this is where they spend the most amount of time. That's in the post training phase. where they spent, and this is sort of anecdotal evidence, and the overwhelming statistic is that they spend more than 50% of their time today just trying to understand issues in their data sets. Lastly, once you manage to launch your model in production, since unstructured data is tied to free-form content created at an astonishing pace in the world, things are changing really fast that the model is seeing, and we need to constantly and proactively keep an eye on out on what is changing, and how can we make our data sets more relevant, and keep the model performance high in production. So now that we understand the entire ML lifecycle for unstructured data, I think the key challenges there are in the pre-training phase for curating a data set, in the post-training phase for fixing your data set to overcome model blind spots, and the last part is in the post-production phase to keep your models relevant.
So I'm really interested in digging into this different life cycle, and like you kind of gave a high level of each one of these. Can we go a little deeper down the rabbit hole on this, and specifically, like, I'm thinking that, when you're looking at things like unstructured data, I know people have talked about how testing can be a burden and how that happens too. And so I'm wondering, as you're looking at this life cycle and you're seeing all these pains, let's like dig into the different pains a little bit more, and then hopefully talk a little bit about testing.
Yeah, for sure. So I guess I'll just take it in the same sort of ML workflow cycle that I described earlier. And so initially, when you're curating your data set, as I said, like we will notice that in the unstructured data realm, effective data scientists generally have a very strong intuition about the domain and the data, and it's more so for unstructured data. The reason is that you need to really understand the nuances about the data sources, and the different, as I explained, different sources of data, different, maybe it's long form data and short form data as one of the examples, different characteristics of the data. Maybe there is noise around the data, and you want data with different kinds of noise in it to make your model robust. And so there are tons of nuances that come in with the data itself at the pre-training phase when you're curating a data set. And it takes a few iterations, and as well as a lot of different I would say creative thinking around getting your data set to a point where it produces effective results from the model. um, but now next on the post training phase, um, as we all know that sort of deep learning can almost be like a black box, and more nowadays that deep learning techniques are packaged in libraries. They are being treated as black boxes versus I guess a decade ago, folks who have had PhDs in data science, they've had a lot of experience, they were writing their own neural networks, and training them. That so there was uh, a magnitude of like extra understanding of the math that's going under the hood. um, Whereas, I mean, I'm not saying that it's required now. In fact, uh, there have been libraries, and even like even course like deep learning courses, like Andrew Ng's data centric AI course, where deep learning has been made very very intuitive, that someone with a sort of just like basic algebra knowledge can build deep learning models today. But what happens when a model mispredicts on something? And I think earlier, and even more so, a couple of years before, data scientists would focus on the model to fix the issues in their post training phase. And so and that was valid because the model architectures and the algorithms then were not generalizable enough. But today, as I noted earlier, we have algorithms that can be applied to a wide variety of tasks effectively. So there's less of a focus on improving the model, and you can pretty much fix a large amount of issues in your model, like bugs in your model, by fixing your data set. So there's an even more importance on actually fixing biases in your data, like trying to look for unknown unknowns that that is causing your model to mispredict. Because if you treat the model as a black box, it's like garbage in, garbage out. There's the sort of the input that is what you need to fix first. So that's the post training phase. And going into specifics, some of the errors that we see in unstructured data especially is, I mean, firstly, sampling errors. As I mentioned, firstly, you're missing out on a few nuances in the data set, and you need to include more of that or augment your data with noise, with different forms of your input. Secondly, unstructured data is heavily dependent on human annotations. Even if even if they're partially semi-supervised, there is always a human component somewhere associated to your data set, and that alone comes with its own, I would say, error potential. um, because there are the annotations need to be done at scale, and of course there are human errors introduced there. And thirdly, there's sort of data freshness and relevance, and that's the piece I talked about, where you need to firstly make sure your test set is relevant, and then make sure that your model is performing very well on that. If it's not, then you need to again go back to your training set and make sure it has the necessary data samples to avoid confusion. So that's the post training phase, and this is where most people, like most data scientists, spend most of their time. And lastly, I think I'll be short here because we can go deeper if we'd like. But I think everyone nowadays is talking about the concept of drift, and more so on the structured data side, because you're looking at distribution differences in your feature set in your training data. But I mean, there's also a very real, I would say, concept of like semantic drift in your unstructured data, and that's even harder to predict these days. So it's very, very important to keep your data sets refreshed in production, and you can only do that effectively at scale because these data sets are huge. You cannot just resample the whole world every month and relabel them. It's costly, and so you need to have an effective sort of almost workflow or an automation built around it to be able to scale.
So one thing that comes up when I'm hearing what you're saying is really it feels like you're going for, and what you're talking about, like as the landscape has changed, there's this data scientist or machine learning engineer that may or may not be the only one at their company that is now tasked with putting into production these models, and they are really the sole responsibility. And I bring it up, it's probably recency bias, because I was just talking to someone earlier about how they are the machine learning engineer. They need to do that. And they also need to train the models, and they need to do the data scientists part of the work too. And I was thinking that it sounds a little bit like this, and I hate using this this term because it's very cliche, but it's like the democratization of machine learning.
Yeah.
And so I just threw that one out there. I know that it is not the best term because it's been overused, but I'm wondering how, like, what's your vision around this? Do you feel like those teams And what you're trying to build is trying to speak more to those teams to help them, especially if they're a little bit smaller, and then they can get things done much faster.
That's a great question, Demetrius, and I think I can speak to the differences between small teams and large teams because, like, I was at Google on a large team, whereas the customers that we're talking to, many of them are these small teams that are almost like a SWAT team of like 2 or 3 people,
Yeah, totally.
carrying the
Totally.
burden of of AI on in the within the company, and that's um, I think that the need for rigorous data analysis and understanding is is universal, right? Um, the challenges that small teams have is firstly is sometimes lack of experience, where it's hard to find folks. Again, I said, like, since we need domain expertise on unstructured data, it's hard to find and hire folks who have years and years of experience in this domain, in this data, um, for training such models, because all these also the democratization is relatively recent. So um, and so that's the challenge that small teams face, and it's since they're small, they're also just working on one model, like one task at a time, and it's almost like we focus on one model for a quarter or two, and then once it's launched, we go to the next model. um, Another challenge that small teams face is they often tend to just launch and forget about the model that they've launched in production, and by forget I mean, like, they might revisit it, but it's in a year's time because they have limited bandwidth to really maintain that model. And so both of these things combined, I think there's a need for data specific tooling that can almost be the data scientist assistant to helping them quickly understand issues in their models. They don't have to run days and weeks worth of experiments to get these insights. And oftentimes it can be proactively given by the tool instead of them jumping and shifting focus. So if they've already started working on, let's say, another model, and there are tools that give them insights. Hey, like, your model is getting weaker on this kind of data. That's a proactive nudge to just ask them to really act on it. And then even like these tools need to also be actionable. And so that's the key part here, where sometimes with the again the limited expertise, limited domain expertise, there isn't an actionable task for the data scientist to do quickly in order to fix it. Like, they'll have to read a bunch of papers and explore the domain better to see how can I act upon this. And the tools should almost give them insights that are quickly actionable to fix the gap in the data set. On on the flip side, with large teams, I think there are a bunch of people building a bunch of models, but and there is a bunch of experimentation as well, and but it's very ad hoc. Everyone runs their own ad hoc Python scripts or SQL scripts on the data, looks at data dumps on their own, and then comes up with ad hoc metrics and insights that they found out, and that causes a sort of like a uniform like a uniformity problem where not everyone is doing the same set of analyses. And how can we rely, like, there's no code review on those scripts happening. And so that's one of the things there, as well as the post production step, where, like, we should be more actively tracking models in production. That's valid even with large teams.
So, do you feel like what you were talking about there with the small teams is a specific unstructured data problem? Because I feel like there may be It sounds a little bit like it could be applied across the board.
Yeah, good question. I mean, so we have you're and you're right. Structured data, especially deep learning applications with structured data, also can benefit from these tools. The only reason why we're tackling unstructured data first is because you can, like, the data scientist can quickly come up with some basic distribution level insights on structured data. Whereas on the unstructured data, it's still very ad hoc. We don't know what metrics to track. We don't know how to understand the data, and it's very domain specific. So there needs to be a standardization of tools there. And they can also apply to structured data. The whole part being like proactive and being an assistant to the data scientist, that still is necessary. But the dire need is on the unstructured data side.
That is an interesting point around like the tools almost need to be unified across. Because I was always going to ask you, like, I always feel that unstructured data as a bucket is very vague and very broad, and like actually, like audio
Yeah.
data is so different. Does how does Galileo handle that? Like, because
Yeah. And it's funny you bring that up because in my experience, I've also seen like the structured data and unstructured data world of ML um, as almost being like a left brain, right brain problem where they both don't talk to each other, and there's a deep divide between the two.
Exactly.
Um,
And one's creative and the other one is analytical. I like that.
Yeah, but I think the unifying factor is the model architectures now. I mean, we sure there's on the structured data side there are XGBoost models that work very well on structured data, but more and more teams are now trying to create embeddings from structured data and of course train deep learning models with structured data. Um, and this is and as this sort of trend grows on in the structured data world, there is an opportunity to unify the tools because when the model uh, becomes the unifying factor, the tools that apply to those models can be shared.
and that leads me back kind of round in a circle to where we talked a little bit about the democratization of data science. And someone recently posted something saying you just don't need to know calculus to be a data scientist, like LinkedIn thing. And like, that's an interesting point actually, because what are you doing? Do you need to know calculus to be able to use the tools, apply them, and get value? And I just wonder where you sit on that kind of spectrum. What's your opinion there?
That's yeah, and I think firmly on the opinion that you do not need to know calculus uh, to do deep learning. I mean, there are there are tasks within deep learning and in even like reinforcement learning that are still nascent, and if you're working in those fields, then I'd say like you definitely would need to understand the math in within the model. But you almost sort of can like, and you have to, there's a distinction I think between like an AI researcher on the modeling side whereas an applied ML engineer. And if you're applying AI, if you're building AI applications, you do not need to know the math that goes underneath the within the model.
Then what we're going to use to gatekeep everyone out? Like, if it's not
Yeah.
calculus.
Which is why I mean I think I have the analogy here about software, and this keeps coming in my mind very often nowadays because ML models are I mean in many cases replacing heuristics within that were built within software. And as we I mean you can think of like in the early days of like Fortran on where like you had to really understand how the compiler worked in order to code. Nowadays, and you like folks don't need to know how the compiler works for in order to build software. And I think it's the same analogy here with models, where the think of the compiler as like the model that's built underneath, that's trained underneath with using the recipe that you're training with. And then if you don't even if you don't understand that, you can still apply that tool to your application.
That's a really cool
I
analogy. I
love
like
that.
that.
Yeah, that is very nice. I wanted to jump in and talk a little bit about synthetic data and the role that you see it playing in the unstructured data world and how it works with Galileo and what that looks like.
Yeah, that's synthetic data is and the need for it is growing. Is I mean I would say like fairly rapidly, but I think that it comes with its own challenges. Um, what we've seen, in our experience, dealing with large data sets, synthetic data can often come to bite you on your foot because it really ties to the heuristics that were used to generate the synthetic data. Like we've been we've in my experience, let's say we've generated um, synthetic speech where we use text to speech models to generate the audio itself, but then you're trying to almost like you're biasing the model towards the algorithm that you wrote to generate that speech in the first place. Also on the on like with my co-founder Vikram, who was on Google Cloud working as a product lead there, they were doing vision models for and they were doing like document parsing models. And if you were to generate like fake W2s and fake driver's licenses, there's just nuances there that were in fact bringing the model performance down because there's obviously some difference in the synthetic data that's just forcing the model to learn the wrong things. And you can also go wrong in other ways where you do too much synthetic data. It needs to be a good mix of synthetic data with real data in order for your model to really benefit from it.
I think that's a really interesting point because it's quite like trendy at the moment. It's quite a hot topic, synthetic data.
Yeah.
And
And
I've never had a good experience with it. I tried to write a semi-supervised learner like about 6-7 years ago, and it was a disaster. It took me loads of effort. It didn't really work.
Yeah.
So
and and I just wanted to add to like Dimitri's second question on how does Galileo deal with it. And I think we with some of our customers using synthetic data, Galileo has been an essential tool in their workflow because they are almost like they almost get quality checks in synthetic data for free, where Galileo can just point out, hey, this is the cohort of samples that are pulling your model performance down. You can remove them or fix them within Galileo itself. And there, like if your synthetic data is bad, if it's pulling the model performance down, within seconds of training your model, you will just see that result upfront instead of having to dig in and find out, oh, this issue is actually coming from my synthetic data. So
that's interesting.
Adam, I interrupted you.
Yeah, no, that's cool. So that kind of leads into. So I was gonna, I didn't have ever had a good experience with it, and so I was gonna ask, like, do you have any other tips for the data science team that have an application that's unstructured data? They just don't have a big data set. Are there any other tips and tricks, or is it like stuff it and see kind of thing?
I mean, I think now we can go in, like we're going into domain specific applications. The tips and tricks are very, very specific to the domain. For example, it's very easy to augment, real samples in the vision space. You can have different coloration. Like let's say if it's an image of a car, you can have different colors of that car automatically. You can have different backgrounds. You can have different noises. You can have people in the like in the picture. You can very effectively augment those things. But if it's like on the NLP side, and if it's on the text corpus side, it's harder to augment that. And speech and comes somewhere in the middle where you can add different noises to that, but you can't really change the voice completely because the voice characteristics are what you're learning from. But and we generally tend to augment the data with different noise samples. On the text corpus, though, even though you cannot augment it, there you can get a bunch of dummy samples from like public. There are more public data sets around text as well, and free corpuses like Wikipedia and news articles and whatnot. So you can be a little bit more creative there around getting that data, but it's still very risky. It's still harder to do in the NLP space than vision. And yeah, so
So now, let's talk a little bit about like the different kinds of users that you feel benefit the most from Galileo, and how you've been seeing them, not only like what has the progression looked like and what are some things that people are stoked about.
yeah. Our customers today range from like small startups with small teams to even Fortune 500 companies, and currently I think some of the verticals that Galileo is being used within are conversational AI, contact center or customer experience solutions, financial services, and healthcare. And I think the progression that we've seen is as we have built out the product, we focused on the post training phase a lot, where like you're trying to find out errors in your data once you're training and iterating on the model, and that's, as I said, like that's been like sort of the biggest piece of the pie in terms of the time spent on fixing the data set, and that's where users gravitate the most. But more advanced teams that have models in production are now starting to build out like active learning pipelines around the whole post production phase, where we Galileo helps them identify which new samples that they should annotate and add to their data set to keep their models relevant. So there's an there's an almost like an automation play as well, where users are excited about, because once they launch this model, they hook up Galileo with it, and then they're almost alerted proactively on when they should kick off a refresh cycle, instead of having to keep tabs on monitoring it in real time.
So leads me to, I think, if I'm say I'm a machine learning engineer, right, in a reasonable sized company, maybe a small team though, and I'm absolutely stoked about the thought of Galileo and it solves all my problems. How do I sell it to my boss, or like how do I sell it to leadership? What's the almost the business
Yeah,
case for dummies? Like a lot of techies aren't very good at
Yeah.
actually communicating,
yeah.
bridging that gap. What's the This is gold
That's
sort
so
of advertisement stuff for you, right?
it's so funny
That's
you say
that's
that, Adam, because I was just talking to somebody yesterday, actually this morning. Big difference, but and they were talking about how, for them to get something like buy-in, they need to not only sell it to their boss, but sell it to their boss's boss, and they have to be bought in. But a lot of the companies that you see out there, they don't, and especially I think there's a little bit of a gap in the MLOps world. We don't really have that literature that makes it something. And the guy I was talking to this morning was like, I need one slide because my higher ups, they're not going to want to get into very much time with this. They just want to see, what is it, give me that one slide, give me the benefits and why we need it, and then get it out of here. They're going to talk for maybe those couple minutes, and then they'll be done with it, and they probably will be looking at their phones. The people that they're pitching to,
mhm.
like, you got to captivate them. So yeah, Yash, how have you thought through that problem, and what are you doing about it? That's a great question.
Yeah, I think the most important thing that resonates with, I mean, there's this is a great question, because oftentimes, like the buyer who's the VP of engineering, or VP of AI, they're a little bit far away from the data scientist who's the actual beneficiary of this tool, and what we've seen work really well is for the buyer to sort of be data centric, and understand the importance of focusing on the data. Sometimes they don't uh, and I've been in that position where I've been leading teams, and you don't understand how much time is actually being spent in this process of fixing, like this, we call it data detective work. um, and it's not only the time. I think like some of our users who are using Galileo, they're getting 10 to 15% relative improvements on their accuracy by fixing the insights that Galileo surfaces. In fact, we're getting amazing feedback where data scientists are saying we found insights about the data that we never did in the past. Since over, even when we're working on this data set for a year. So it's like, it's just because you don't run all possible sets of experiments, uh, and the algorithms that we've developed go deep into the model layers as the model is training. So you need that level of deep rigorous experimentation to surface these insights, and that is what Galileo brings out of the box. And and that's where leaders who understand the importance of data centric AI, and application of AI being even more data centric than model centric. That's the thing that leaders need to understand to really see the value in Galileo.
Can you say that last part again? The applications of data
Yeah.
centric
So
over model centric?
yeah, the so most teams, and this is even more true for smaller teams, but most teams out there are applying algorithms or models on their data sets, which is also saying that they're basically tuning some hyperparameters for the model and then training their model on their data set. In If you're doing that, if you're not building your own neural network architectures, or tweaking the architectures for your use case, which is more than 90% of the cases now in terms of the teams that are applying machine learning, you do need to be data centric in your in the amount, and in the, I would say, the importance you have for your ML workflow. For example, like if I'm a leader, I'm allocating time, or I'm allocating budget on like where my team should focus. I think having a key data centric focus is a key way to succeed with working with unstructured data, especially.
So obviously, in a really talented team, loads of great experience, worked with some great people. Have you got any horror stories for us, or war stories? Any kind of like biggest dog moment or anything like that?
Well, I mean, I think there were a fair share of, I would say, embarrassing fiascos in production, and this is where all the learning comes from.
Yeah,
I
totally.
think um, I mean, there were cases where, like, I'm not going to sort of name names, but there were celebrities and prominent figures in the world where we try to make recognizing their names and sort of their names better. I mean, for example, a famous query that we worked on was how tall is Barack Obama, and then we used it for all the demos. But there Barack Obama was actually like an easier word to recognize, but there were a bunch of things, and this is stemming from the fact that the world keeps changing. Like um, like the person who is the president of the United States changes every 4 years. Uh, the winning football team changes every year, win Super Bowl, and so you got to you got to be mindful of that and make sure your models can recognize those things. COVID was another example where everyone was going into lockdown, and like data scientists had to scramble working from home, but also updating their models to understand COVID related terms, to serve users best in production. So that's that's sort of the reactionary or reactive aspect of working with unstructured data, deep learning. that's there today. If you have these tools that make almost a proactive signal, or give you a proactive signal around these difficulties, you wouldn't have to face these horror stories in production.
I want to finish with a few rapid fire questions, if that's all right with you, Yash. First
Yeah,
one is,
that seems fun.
what was the last book you read?
I think I read The Trade-Off by Kevin Manny. I have it here and been
Nice.
reading it.
Okay, cool. What was it
It's a
about?
good read. It's I think it's about sort of the tension between sort of like working on quality and convenience. I mean, in your day-to-day sort of engineering workflow, you oftentimes prefer convenience over quality. You would cut corners, and it's fair to do in some cases, but I think we need to, especially I think, if you're leading a team, if you're part of a team even, and a data scientist or an engineer, it's a very good sort of way to think about how to be cognizant of how much corner cutting you're doing, basically.
Oh, that sounds amazing. We'll
But
leave a link to that.
that's the latest one read I was doing. Yeah.
Tell us about the last bug you smashed.
Interesting. I mean, the last bug I smashed was, I mean, I think interesting thing within Galileo, where we were looking at. I mean, it was a strange sort of. Not, I would say, like, not a bug within the algorithm, but it was a bug within the UI that interacted with the API. And it was now that I not only work on data science. I'm managing a team of cross-functional folks, as well as ML engineers. And the interesting thing was like fixing an issue with the visualization. I think we've done a lot of hard work within Galileo to run powerful clustering algorithms in the embedding space, and surface different visualizations that help you highlight things within the embedding space. And I think that the last bug I fixed was like making that embedding space visualization with clustered by a specific insight that we provide better.
Nice. All right, so you are now a co-founder of a company in Galileo, and you probably have talked a lot about marketing. What's the most ridiculous thing you almost did on the marketing side?
That's a good question. I mean, I think that the ridiculous thing I did on the marketing side is kind of like not focus on marketing. So it's I think that tends to be in the early stages of a company, like founders don't really think about marketing. And I think I'd say, like, in hindsight, to like almost start thinking about marketing sooner rather than later in your journey. Folks think that, you can almost like bootstrap the company to up to for product market fit, with founder led sales, and that should be enough. But I think every company needs to think about how we can improve, or create mindshare about the company itself. And we've been thinking a lot about that, especially because Galileo is in this space where we're creating a category of tools here. There are no tools in the data scientist workflow today that help us, almost like we call it ML data intelligence. And we there is a need for ML data intelligence now more than ever in the ML workflow. So
Ooh, I love that word, ML data intelligence.
that's a marketing tip.
There it
Like
is.
it, like
Yeah,
it.
maybe we name That's what we should name this this podcast. I like that a lot. So, last one for
Super.
you. What piece of technology are you bullish on right now that might surprise people?
I'm quite bullish on quantum computing. I mean, I think I've been like I know that we're still very early in that journey, but I think we can leverage you know multiple orders of magnitude more of computing power. I mean, as we all know that like sort of Moore's law is flattening now, and we're trying to do sort of things with distributed computing and making sort of accelerators and that to almost like keep Moore's law going. It's almost like we're hacking Moore's law, right? Like with being able to run certain pieces of our software faster, and so um, yeah, I think, I mean, like I'm extremely excited about the work that's happening in the quantum computing world, and very sort of bullish on that on the outcome of that.
Nice. Well, man, this has been a pleasure.
Yeah.
I really appreciate you coming and sitting down with us, Yash, and teaching me a little bit about this unstructured data world that I don't get to talk about enough with people, or I always love talking about it. And we'll go ahead and end it right there. Thanks again, Yash.
Yeah, thanks for having me, and love the discussion we had, and hopefully hopefully we start thinking more about like unstructured data as we start applying it more in the real world.